My name is Alistair Rendell and I'm the Deputy Dean for the College of Engineering and Computer Science here at the Australian National University. I would like to start by acknowledging and celebrating the first Australians on whose traditional lands we meet and pay our respects to the elders of the Ngunnawal people past and present. Welcome to the second in our series of Inside the Researchers Lab. We are honoured today to have two eminent researchers with us, Professor Heike Ebendorff-Heidepriem and Professor Chennupati Jagadish. Heike is a member of the School of Chemistry and Physics at the University of Adelaide and Deputy Director of the Centre of Expertise in Photonics. Jagadish is Laureate Fellow and Distinguished Professor here at the ANU in the Department of Electronic Materials Engineering in the Research School of Physics and Engineering. The format of the event will involve me asking each of our guests a series of 10 questions, and then we will then open the floor to questions and follow that by some refreshments in the room next to here. So, without further ado, Heike, what makes a good research problem?
I think the first thing is that one has to be passionate about what one wants to research. So I think that's the first thing, that you have to believe in the idea, the topic you want to pursue, that you are passionate about it. Of course, you can be passionate about a lot of things, even things that are impossible, that are against nature's rule in the universe. So then the next thing is therefore that you choose a research problem, a research topic which is something new, which hasn't been done before. Also there are a lot of things you could do what nobody has done before. So I guess then the third condition I think is also to look into that what you're researching is that it will advance fundamentally the science, so that you advance the knowledge, that you can achieve new insight in science, or if you do a more applied research, that you develop a tool or a technology which can be really useful, like a tube. So I'm from the Institute for Photonics and Advanced Sensing, and so we are pursuing new sensing technologies which then can be used for medical diagnostics. So it's an example where it's more in the area of applied research.
So have you always been passionate? When did you find your passion? Can you be passionate when you're a PhD student?
I think you can. I think it's important that you're passionate so that you can see it through really, because there will be tough times where I also question myself, do I want to do research? But then I thought, no, this is what I want, and so I see through these difficult times.
Yeah, I agree with Heike that in terms of the fact that you need to really feel passionate about what you do, and without the passion, and I don't think you'll be able to solve really challenging problems. And also one need to really choose a problem which is really challenging, and if you solve that problem, the international community really take notice of you. That's very, very important. And you can go and take a problem which you solve and then nobody really bothers about it or otherwise cares about the solution of that problem because it's not a major problem or otherwise problem is not really of interest to the international community. So that's why you really need to really put your research into context internationally and where this stands and is it going to make an international impact or not. And so combination with the perseverance and the passion, and also you need to really choose a challenging problem where you're able to make a major breakthrough in that particular field. Then immediately people take notice of what you're doing, and then of course it will have a major impact in that particular field.
So any comments about finding a research problem? Any thoughts on how you find the research problem, especially as a new emerging researcher?
Yeah, the best thing is to really see in the do literature survey and identify what are the hot topics people are really working on, and then also particularly in the early stages of development of a field. Even if you really solve a problem after maturing of the field, then probably people will not really pay that much attention because the field is now so matured, and your solutions or whatever the problems which you're working on are too small within a huge field. particularly if you really go and choose a problem which is at the early stage of development of the field based on the current research, and then particularly journals which are looking at what are the hot topics which are coming up, and then you go and choose a problem in that area. But also if you do that one when you're applying for grants and other things also, the reviewers and others also feel that, okay, this is an emerging area, it's worthwhile to fund that one. It becomes much more challenging to really find problems in a very mature field which has been there for 20, 30 years. And then be able to excite people that yes, the problem which you're working on is really important problem, and then it becomes a challenging thing.
Mm-hmm. So Heike, what do you know now that you wish you knew when you first started?
I find this a very difficult question. I mean, I have it so often in my career, almost every few months or so, that, oh, the virtue of hindsight, if I had known this beforehand, or I should have seen it. So I had this several times. Just to give maybe a concrete example, so my research area is in developing new optical glasses. And so I was developing this telluride glass, and I was, at some point, I found gold crystals in the glass. It might be nice for jewelry applications, but we didn't want to have them. And so I had the choice then to go up or down in the temperature at this point to avoid the formation of these crystals. I've chosen to go up in the temperature, and now 3 years later turns out this was not the best choice. Having said this, I learned so many other things things by chance, that maybe because I went up in the temperature, this might be a way of forming not gold microcrystals but nanocrystals, and they might be turned into something really useful. So for other applications I don't want to have gold in the glass, and then now I find out if I go down with the temperature, this might be the right way to do it. So this is one concrete example where on the one side, oh yeah, it would be nice to have known this before, a few years earlier. On the other side, so I got on a side track in the research, which might lead now rather to a major research topic.
Mm-hmm.
Well, my background is in physics, material science, and electronic engineering. So that means my research interests are very broad. So particularly when you're working in a broad field covering a broad spectrum of research activities, sometimes people cannot really associate you with any one particular area. If I have to really go and start my career, and then I will go and focus on one particular field and then make a name for myself and then move into the different areas, rather than being able to go and then start, because I'm so excited about so many opportunities and also ability to be able to contribute to so many fields. You end up going those things, and then, but the problem is that from a particular field, people know you only one aspect of your work. They really don't have the full picture of what you're really contributing and then what you're achieving. So that's why if I'm starting my career and I will go and choose a particular field, spend a few years, make a name for myself, and then go and use my other interests in expanding myself, so thereby people can always associate me with one particular area. So that sometimes helps you in terms of scientific career. And because people sometimes ask me, well, in fact, every time we want to nominate you for one recognition or the other, it's always difficult to really identify, out of so many things you have done, some unique thing which you have done we can associate you with, sort of thing. So sometimes that can lead to some, if you want to call it as frustrations, but the best thing is to really choose something which you feel passionate about and work for a few years and make a name for yourself. Like Kylie Catchpole, for example, is well known for plasmonic solar cells. So that means even if now she goes and drifts off and to do into other things, but at least people can immediately associate Kylie to the plasmonic solar cells. That's one example, for example.
So you're saying focus?
Focus is very, very important.
But don't you think that some of the major advances comes from perhaps moving between areas? They
do, but that's why the thing is that if you really try to do those things at the early stage of your career, then probably people don't associate with anything. So that's why you just really make a name for yourself in one area and then go into other areas where you'll be able to make across the discipline boundaries. And in fact, the strength of my research group is our ability to be able to do physics, material science, and electronic engineering. So when you're thinking of devices, you know also what are the material science problems which you need to deal with if you want to make a high performance device, or if you're really looking at materials issues, what are the critical issues which you need to address in order to make a working device. And also you need to understand the physics of these things. So thereby the combination of three are the ones really allows us to be able to make a major impact internationally. So that's an advantage one way, but at the same time, when people are looking for what you have done, and then sometimes people find it difficult to associate it with one single major discovery or development sort of thing.
So what motivates you?
Is solving a problem. So we have this always in research. So this really motivates me. Or there's this problem, if it's an engineering or science problem, and I want to solve it. This is really one aspect. The other is making, so I'm working on glasses, and therefore I think the luxury when we develop a new glass and it works, and then you see this beautiful piece of material. This is really something hands-on work. This also motivates me. It's also working, what I like is with the students, with staff. So to see their faces once they cracked a problem is also really a joy to experience this. And so this is what keeps me going, really, through the more difficult times. So these are my motivators.
What detracts you from that? Administrative stuff.
to do administration work, to sit too much on the computer, not being in the lab. So sometimes, therefore, I try just to take a break, go in the lab and just look around what the people are doing, have a chat with them. I find this really, also for me to catch up, not to lose somehow the touch of the hands-on research technology.
Okay. You are talking to a computer scientist here who considers the laboratory very dangerous. So Jagadish, what motivates you?
Well, I agree with Heike in terms of essentially solving challenging problems in science and engineering, really very, very satisfying, particularly problems which are given up by others, or otherwise others are finding it is difficult to really find a solution to the problem, and whenever you solve that, and then it gives you enormous amount of satisfaction. And another area which I really feel passionate about, and then really gives me enormous amount of satisfaction is my training of my students and postdoctoral fellows. And seeing their success, really, there's no reward which you can really match with anything which you see your students been so successful in different areas which they end up going and choosing. And then in those chosen endeavors, and they have really been successful, and it really, you feel so satisfied. People whom you've trained are the ones, those are really changing the world. It's an enormous pleasure, and it's a great privilege to be a university professor and then be able to make a huge difference to a younger generation of scientists and engineers. And also mentoring young scientists all over the world, and I enjoy that very much. And so it's again pleasure to see them being successful, and it's fun.
So do you enjoy the laboratory or the...
Yes, I enjoy the laboratory, and then if I tell my students or postdocs or my other colleagues, they say that what laboratory you're talking about, you're in front of your computer all the time in your office. So that's why I tell my students it's very, very important that being a PhD student and postdoc is the best time of your life, have fun. And so most of the time, as you know, that whenever you become senior, and then you're spending more and more time in front of doing lots of other things which you need to do. So I tell my students, I have got an open door policy, and I ask my guys to really knock on my door anytime they want to. And we don't want to disturb you. No, I say that, no, you're not disturbing me. You're helping me to get out of the stuff which I need to do, but having fun talking to you about science and solving the problems which you're discussing, interpreting the data and interpreting the results and other things, that's the most fun part of it. But unfortunately, being a senior researcher running a group of about 25 people, and you don't have the luxury of going into the lab and then be able to do your own experiments, which I used to be able to do for about 10 years back or so. Then my downfall started in 2000. I became head of department. That's from that day onwards, I'm not able to go into my lab and be able to do the experiments. Of course, I walk into the lab and talk to my researchers, but not been able to do my own hands-on experiments, which is really the fun part, and that's why you go and choose science and then do that. But I had a choice of either I do that one and then I allow other things to slip, or otherwise you just say that, well, it's my job to really do the things because others cannot do these things which I'm doing, and I'll go and do the things, but do my research through my students and my research fellows in the group.
So have you reached a stage when you walk into the laboratory and the students consider you too dangerous to be in there?
So all the time, Alistair.
All the time.
And so then basically, in fact, it's funny because sometimes recently, I think a year back or so, Minister Kim Carr came to our lab, and then our director asked me to show some of our lab, and I was there. And then my students were joking me, only time he comes into the lab is whenever the ministers come, sort of thing, you know. So, of course, this is one of those downsides of running a big group and also with lots of facilities, sort of thing, which always is challenging.
But I guess you not only really need to be in the lab, really talking to the people at the meetings, so asking them what they're doing in the lab. I also find is that you really get also a very good picture. I also enjoy it then to hear about their experimental challenges and how they solve them.
So, what didn't work for you?
What didn't work for me? Totally forgotten when I thought about this question. Yeah, one thing is, I had one time also where I'm working, so it's really 10, 15 years ago, where I was working more really on my own. I felt a little bit isolated from the group, and this really didn't work for me, I realized. It's really being part of the team is very important for me, to have the exchange with the people, because if you have a problem and then you have several people, colleagues you can go to, this is really helpful, just to talk to them, then to figure out how to solve this problem. So this is what I found. It's very important for me to have this base of people around me.
So how do you promote that or achieve that? Or have you done that through sabbaticals or visits? Or
it's really at building more a network of people is at the conferences and to talk to the people. And also I try more and more to set up collaborations, finding the funding of really pursuing the collaborations, because this is what I find challenging is, yeah, you speak to people and you come up with a common idea how really you could do complementary research, but then you need to have the funding so that you can employ a person, have a student, so that really you can pursue then the collaboration. This is then a challenge which comes with it.
So I think in our previous colloquial, one of the guests commented that the chemistry is very important. So it came across quite strongly that the chemistry of the interactions is extremely important.
That's, yeah, fully agree.
So Jagadish, what did it work for you?
Of course, many things didn't work for me, and that's part of life. Means if everything works according to our wishes, probably life is boring. So in life we always face lots of challenges, and then getting over those challenges is the most important thing. So many things which I can give in examples in my life. And my parents wanted me to be an engineer, and then but I didn't do very well in my year 12. So then I ended up having to go. I couldn't get into engineering program, and then I ended up getting into physics program. So
we always knew that was the case.
So then when I finished my 3 years bachelor's degree, then I ended up doing MSc Tech. It's a 3-year master's degree. Essentially, that is mainly essentially electronic engineering. And so then I ended up doing engineering by a back route, if you want to call it that way. And then, of course, I'd gone off and then did my PhD. That was in material science. So that's how I ended up having my physics and electronic engineering as well as material science background. And after finishing my PhD, and I was working as a lecturer, and then I was trying for lots of postdoctoral positions, and I was applying for every job which is advertised in IEEE Spectrum and Physics Today, and none of them worked. And if I say that it's not in the double-digit figure, and then I had a triple-digit figure as regret letters, and then you'd be surprised today. It doesn't matter. You only need one offer letter. How many regret letters is not something which you should focus on. The offer letter which you got, one, is the most important thing. How you make use of that one to really set yourself. In fact, I had to change my field. I'm a semiconductor person, and I ended up getting a postdoc in magnetics, and we were doing detection in oil and gas pipelines by magnetic techniques, corrosion in oil and gas pipelines, while I was at Queen's University in Kingston. And then another professor who happened to know that I'm a semiconductor person, and he's the one who asked me one day, Jim Williams is starting a new department at ANU, will you be interested in going to ANU? So I said sure, and then that's how I ended up coming to ANU on a 2-year contract 22 years back sort of thing. So we always face challenges in life, and our ability to get over those challenges and persevere with the problems and never give up, and then be able to really get over the adversity, and then be able to, you can achieve anything. And always think positive, don't allow the negative thoughts to come in, despite the fact everything is falling apart. Because the positive thinking will allow you to be able to get over any problem. And perseverance is, of course, is important. Hard work is also important. If somebody denies you something, work harder and prove them wrong. Not working less. That means you're proving that they are right.
So perseverance.
Absolutely.
And learning from your past experience, I guess. And I guess fundamental is passion.
Absolutely. You have to choose something you feel passionate about, otherwise it's not worth doing it. You don't want to choose something where for the sake of comfort or safety, and after 40 years you look back and say, I wish I have done something different. That's a wasted life, and it's not worth it. And also in science, unless otherwise you are passionate about, or choose something which you feel passionate about, science is a hard slog. And we spend long hours and things work, don't work, and all these things. But you're really working in a field which you're feeling passionate about, and you don't feel like a hard slog, and then you really are enjoying it. People ask me, how can you work 12-hour days, 60 or 70-hour weeks for 20, 30 years? I'm having fun, guys, so that means, really it's not work for me. I'm enjoying myself, and that's why you need to have the passion, and you choose the profession or the field which you feel you enjoy it.
So how important has money been for your success?
Very important.
Very important.
Very important, because without money I can't do any research. Because I'm doing experimental research, which is not cheap, it's quite expensive. And so without money is also, pays my salary, it pays student, it pays staff. So money is very important, which is sometimes unfortunate. And so therefore I guess we all strive to get for the funding opportunities so that I can pursue my dream of research. And so sometimes it's hard to write these grants, but then I think I want to do it, so I go through it so that I have the money so that I can pursue it. And then it doesn't feel so bad, so gruesome anymore, because I have the goal. Why am I doing it behind it?
So any particular tips on how to pursue funding or funding sources, or?
It's really looking out there what schemes, what opportunities are out there, and then look which one fits your research, and try it as often as you can. So it's again what we say several times, really perseverance, which is important, and not to be, if you didn't get funding through, then try it once more, improve your proposal, and then the second or the third time, most likely you will succeed. It's really, again, not to lose the passion and that you believe it's a great research problem. I think it's important.
You mentioned that you've been successful in the linkage project recently.
Yep.
So you've been working with industry as well.
No, it's a LEAF grant.
A LEAF grant. Okay. Did you have interactions with industry?
I had a little bit interaction with industry. I didn't find it so easy for me, so I never have really led a linkage grant to myself. So I talked to industry, but I never got to the point of really having then progressed an idea, a topic so far that we could, so that I felt comfortable to put it into a linkage grant. So for me, I'm at the stage also where I really try the discovery projects.
So Jagadish, how important is money being to you?
Money, personally, for me, is not that important. Money doesn't drive me personally for myself. For my research, of course, it's absolutely critical. And without money, you cannot really do anything. And I would like to quote Nobel laureate for chemistry, Alan McDermott, and so he happened to be Kiwi, unfortunately he passed away. And then he used to say that ideas without money is hallucination, So in other words, you may have great ideas, and then if you don't have the resources to be able to really explore those ideas and then be able to really pursue those ideas, and it becomes very, like, you're imagining yourself sort of thing. So that's why it's very, very important that you need to have the right kind of resources. And I've been lucky that during the last 22 years or so at the ANU, we've established more than $20 million worth of facilities. And so, of course, my group is very much reliant on the discovery projects and fellowship programs and linkage projects and both industry as well as equipment grants, and very much on the ARC funding sort of thing. And so that's absolutely critical, without which we just can't do research. And particularly in experimental research, and everything costs you a lot of money, and you really need to have the right kind of research money to be able to really pursue research in our field.
So any tips on how to be successful in those schemes?
And of course, be strategic in terms of what programs which you're applying for, and also that really also think about who will be the reviewers for your proposal. And so we may be doing our own research in our own corner, but they may not be even aware that you exist, and then you're doing research. And then just go and visit them and give a seminar in those departments, so thereby they know what you're doing here. Or otherwise invite potential people in your field to your own university and then ask them to give seminars and then show them what you're doing. So thereby you remove that barrier, and then particularly when your people are ranking proposals of similar quality, and then obviously anybody who will rank a proposal whom a person they know slightly higher than the ones they don't know, so they may be equal based on their own track record and then the proposals, but if they know you, then most likely human nature is that they'll try to rank you slightly higher. So that's why it's important that you really network and then just go to the local conferences and then present your work. And lots of times my students and my postdocs, they prefer to go to international conferences and present their work. That's perfectly fine. But then the local community does not know you because you never turn up at the local conferences. It becomes very, very important you also go to local conferences and present your best work. So thereby your best work is known to the local community, and most of the time they are the ones those are really assessing these proposals. It becomes very, very important from that point of view.
So there's some strategic thinking.
Sure, absolutely, absolutely.
So, but also fundamental is a good idea.
Of course, you need to have a good idea, you need to write a good proposal, and then also you think about in terms of who is going to read this proposal. Remember that most of the people, those are reading this proposal, need not necessarily be specific experts in your field, but potentially it may also go to an expert in your field, and that's where your ability to be able to balance a proposal where a journalist can also appreciate the research which you are doing, how important that is, but also specialists, those who are in that particular field, also can appreciate what you're doing. So that's a bit of a balancing act, and you need to get that one right. If you don't get one right, and then a person who is not an expert in your field, you lose them after reading the first page, and then of course your specialist person may say all the wonderful things, but you got a mix of scores which you've been given, and if you get, I have been told recently that you get 1C, forget about it, and then you will not get that grant. So that's why it's important to be able to get A or Bs from all the reviewers, both the people, those are non-experts in your field as well as experts, and that's where the challenge comes. Think about from the other's point of view. A person who doesn't know anything in my field, how can I excite that person about what I am doing, and the problem which I am solving is important, and also it is timely. You don't want to also give them the impression, yeah, this is important, but it may not be that urgent to really fund this one when I've got another project which I can fund sort of thing when you've got limited amount of funding. So that's why it becomes very, very important.
So do you have any advice for your students or postdocs who are about to prepare grants?
So generally I tell people, first and foremost, you get good publication record. And it is very, very important that you publish good papers in good journals in your field. And so mix of first author papers and co-author papers are important, and particularly if you're at the early stages of your career, because you're a co-author of lots of papers, but you're not a first author. People assume that you're a contributor to the work, but you're not the driver. So that's why that mix is very, very important from that point of view. And then again, once if you write a proposal, ask one of your colleagues, those who are not directly involved, to have a look at it. And then because they really don't know anything what you're doing, and then they may come from a fresh perspective, like a person on the panel who doesn't know anything about your field, or at least they are probably an expert, a computer scientist, but they may not be a specialist in that particular area, for example, and still be able to really assess that one and then feel passionate about it and feel that, hey, that's a very interesting proposal and I would like to fund that.
advice I have apart from all this is try to explain or convey what you want to do in 2 or 3 sentences. Try this on several people, because it's really, it helped me. It's very tough to do this, but then it really, you get the main message across. So really try to excite the people in the 2 or 3 sentences. And this then will also help you to write the proposal and also to test it on people. You see, is this really what excites people?
And start early.
That's true.
Sure. Yeah. Lots of times, yeah, that start early is an important point, because lots of times people end up giving me 24 hours before the deadline, can you comment on it? Then of course, then you're not going to change the entire proposal. There's no time for it, and then you only try to really suggest cosmetic changes. So that's why more time you give it to other people to really review your proposal, and then more substantial changes they can recommend, and that may help you in terms of really rethinking about your proposal. That will help quite a lot, and that's very, very important thing from that point of view.
So what is your best advice to novice researchers?
We talked about it already so often as perseverance. It's really persistence, perseverance. I think this is, I've seen this over and over on students or postdocs, that they were at almost giving up, but then I really try them, persuade them to see it through, and then they come out of this really valley, and then they crack the problem, and then it's suddenly they speed up in their research with, I don't know, 2, 3 times. So it's really the perseverance, I think, is the most important thing.
I agree with Heike, and of course you need to have, first of all, passion, important thing, and then choose a research field or a topic which is internationally hot topic, and then of course persevere with the problem which you're working on, and then also build up a team around yourself, and particularly choose students or postdocs, those are smarter than you. And that's very, very important. Sometimes people don't want to do that one. That's an important one. I think it's important to have people surrounded by you or much smarter than you are, and as a team that helps. And find collaborators, those who are again smart and also complementary expertise to you have got, so that way collectively you can really be able to make a major impact. And we cannot be experts in everything, but having complementary expertise and collaborators can also make a lot of difference. But also sometimes they may write some papers and you get the credit for it, and you write papers, they get credit for it, and it's a win-win situation. But again, you choose collaborators carefully so that they are people with whom you can go and have beer with. In other words, that's people whom you can be friends with, and then you also develop the mutual trust between each other. And being generous to your collaborators never hurts you. In fact, that's my philosophy, is that being generous to others never hurts you. But so in other words, it's a pleasure of giving to others, and also others will reciprocate back. And so that's why it's one of those things which, of course, this doesn't happen in the early stages of this thing, but that's something which you need to gradually build up as a philosophy. Work hard, work smart, and develop good communication skills, both oral and written. You may be a great researcher if you cannot communicate effectively to the people whom you are presenting your work. They may not feel excited about what you're doing. If you don't know how to really communicate in the written form, and again, they may not appreciate the wonderful work which you're doing, and again, the communication skills become very, very important. I come from a society where you're looked down upon if you're really talking about yourself or your work, but because you do your work and your work should speak for itself. Of course, that's all well and good, but when the world is so busy and they don't have time, at least whenever you get an opportunity, then you really need to be able to effectively communicate what you're doing, so thereby people can really appreciate the excellent work which you're pursuing, sort of thing.
So any suggestions on specific things to improve communication skills?
Of course, you need to again think about when you're presenting, what you're presenting, and then, again, what your audience is, and so thereby you always tweak your talk based on the audience. And because I end up going and giving talks in physics conferences, material science conferences, my device conferences, and then of course all my talks I always tweak them, because if I go and talk too much physics to a device conference, you lose them very quickly. But whereas if I talk too much about devices to my physics conferences, probably I lose them also very quickly. So that's why you really need to know your audience and then really tweak your presentations, whether it's in the written form or in the oral form, to the audience, so thereby you're really doing the right thing. So don't give the same talk in the same way, irrespective of what the audience sees, and then it's going to be very difficult to really excite people.
What irritates you the most?
If I have a problem or an idea, and then I would really like to pursue it, work on it, but then there are so many other things I have to do in administration or other things, and so I find it then very difficult to sort of pause, let go on this, pursuing this idea, and then working on something else. This is what I find the hardest for myself, to do this.
It's a lack of time.
Yeah. So lack of time is also then I'm doing this one, but now I have to stop and do something else. So this switching between the tasks, we all have so many different tasks. And so it's really this switching between the tasks, which sometimes I find really hard to do.
For me, filling forms for the sake of filling forms to keep certain people in their jobs. And so that's, you know what I'm talking about. And so it really irritates me quite a lot. And also I don't like people, those who don't know what they're doing, telling you what to do, which again doesn't really, interest me. More in terms of people, those are in the bureaucracy and then on layers of bureaucracy and all those things, and they just waste a lot of your time. And instead of those people helping the researchers to really enable them to achieve their goals, if they end up asking you to, we want you to fill this form because of blah, 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 then you end up spending a lot of your time, and that really irritates me quite a lot. And so that's sort of, it's a waste of my time, but I don't have any choice, because these days you get so little administrative help. Of course, department administrators are there to do the general stuff, but we all have to do everything on our own, and it really doesn't help you in terms of really getting on with your life and do other things which you need to do. And then you're really spending a lot of time in doing a lot of trivial stuff.
So has it got worse over the years?
Absolutely. And so 22 years back to today, and then in fact the ANU has moved towards another layer of administration, so that means those administrators ask you to do something. And so I'll give you an example, which is a fun one, which most recently happened. So then in the ANU, as most of you know, that at the end of the year we have to fill up this form, 52-day rule. That means you're allowed to do 52 days of your year on things other than the university business which you're doing, like consulting for other people or whatever it is. So then they send you something and you remember whatever the work which you have done for industry or whatever it is, and you fill that form and you send it off. And then after 6 months, one administrator contacts me and says that, you have done this one, you need to apply for permission to have done that work. Because the purpose of that 52-day rule was to really give flexibility to academics so that they can do what they want to do and then report to the university, so that the university has a record of what they've done for outside world. And then there's no need for permission for that one. But now this person said that. Then I said, okay, that's all fine for me, but can you please send me the form? I don't remember what number of days I put in. Can you please send me the form which I filled 6 months back, so that I can really fill the right number, so that I will seek the permission for the right number of days which I have been out? I haven't heard anything back, because they don't have a clue where they filed the form. So that's one example of, I can tell you, that what irritates you. Those are things which are extremely frustrating and the absolute waste of time.
So do you have any tips on, you say lack of time, any tips on how better time management? Or?
It's, as I said, it's not necessarily time, it's from really switching between the different tasks. Yeah. This is what I find difficult. Haven't found a solution to it yet. Then, accepting that that I have to do it.
What is on your research bucket list?
I guess I have. There are many things, maybe too many things.
So a large bucket.
Yes, I have a large bucket. But if I pick out 2 examples, one is my research is developing glasses and also then turning these glasses into optical fibers, and these fibers have a structure in them. So microstructured fibers, they have tiny holes in them, and so going from the glass to the fiber in between, we are making the preform. And we use the so-called extrusion technique for doing this. I'm doing this already now for several years, 7 years or longer. And all the work was done really on doing this extrusion with glasses up to the range of 600 degrees Celsius, because it was really an engineering problem. Up to 600 degrees Celsius, you can use a stainless steel die for the extrusion to squeeze the glass at the high temperature to this die. And now it comes really talking to several people. There's really the dream of going up to higher temperatures so that other glasses, like for example quartz glass, can be extruded in the same way, so that very different structures can be also made in this glass. And so this is a little bit an engineering problem which I pursue. And so there is that I talk to several people, what glasses do they have, what these high temperature glasses, where would it really make an impact if we can extrude this type of glass. So this is one on my list. The other is to combine nanoscale properties with bulk or macroscopic properties. So putting nanocrystals into a bulk piece of glass, so that you have then a material which you can touch, which you can form into a waveguide or a fiber, but it has the nanoscale properties in them, so that you can harness the nanoscale properties in an easy to use material. So this is another really big theme research topic which I want to pursue, and where I started with nano diamond particles, but I really want to extend this to gold nanoparticles or upconversion nanocrystals, really to see, to cover a broad range of nanocrystals or nanoparticles. So these, I think, at the moment are my 2 big research topics.
So do you see yourself continuing in a university type environment? Do you see a radical change to industry, or become an administrator and then fix all of the problems which...
Now I think I'm very happy in a university environment. Mm-hmm. So at the moment I have no ambition also to go to the industry. Mm-hmm. So I like it at the university.
And of course, too many research topics which we are pursuing, and then we have lots of things which we want to pursue, and then at the moment we are working on these metamaterials. These are engineered materials which will end up having negative refractive index. So that means the light will be bent in the wrong direction. So that means you can really create things like flat lenses, and then also you can enhance interaction of the light with materials so that you can improve the performance of the devices. And particularly with Professor Yuri Koshar's group, and then his group is doing theoretical work, and we are doing the fabrication, and that's really an exciting area, and there are an enormous amount of opportunities, because there is a potential for major discoveries and also developing new technologies which are currently not existing. Another area at the moment we are working on is nanowire solar cells, and again these nanowire solar cells are expected to be low cost and high efficiency, and again in the solar energy area one of the issues is how to really improve the performance by reducing the cost, and there's always a challenge, and particularly the nanostructures provide opportunities for you to be able to really manipulate the light interaction with the material, which can significantly enhance their performance. And at the moment we are working on nanowire lasers, so we just made our first laser, and which is optically pumped, but of course ultimately we want to make it electrically pumped laser if we want to really use it for applications. So the list is long, and but challenge of course is that you've got so many things you want to do, but of course you have a limited amount of time and limited amount of resources. And I also don't want to increase the size of my group because of the fact that 25 people is a group size where I can really interact with each and every one and be able to really discuss a scientific problem. Mm-hmm. And if I increase the size much bigger than that, then I become a science manager, which I don't want to become a science manager, and I want to stay close to science. So that's why keeping your group at the right level and still be able to really look at exciting problems, and so we're having great fun, and we have lots of things to do, and of course money is always an issue, and then of course if you can get more resources, and that always helps in terms of more postdoctoral fellows and others, those who can come and assist us in terms of pursuing some of those problems.
So you don't see yourself becoming a CEO of a company? Or
Yes,
has that been tempting at all?
Yes, of course. That's an interesting question. And some of my students are CEOs of companies, and they're making 10 million blue LEDs or white LEDs a month in China. It's an immense pleasure to see their success, and they're running companies with 300 or 400 people and enormous amount of automation and all these things. And I think my students are smarter than I am, so then they know how to make money more than I am. And so, as I said, that you need to have passion for money if you want to really go into industry and then really pursue some of those pursuits. And having started a company about 12 years back in commercializing some of our semiconductor laser technology, and spending about 18 months and the 60, 70-hour weeks, 7-day weeks. I've learned a lot about how to commercialize and what are the challenges in commercializing technologies, and then what is the big gap between what's been done in the universities, and then how do you, in order to be able to really commercialize the technology, and you need to really develop the manufacturing processes and suitability of the techniques which you're developing for manufacturing applications. And there are many challenges out there. And then it turned out that after 18 months, our company had to be closed down because we were about to get $20 million funding to really keep this company going. And Nortel Networks in Canada has announced job cuts. And so in the process, then our investors got cold feet and pulled out in the last minute. So then I realized that you may be passionate about your science, you may develop a great technology, but the market can change very quickly, and then suddenly you become a history sort of thing. And more importantly, I've learned about myself. And when I was running this company, it's the business guys are telling me what to do. And as you could imagine, I didn't like that at all. And they didn't know what they were telling me to do, but they were telling me to do. This sounds like our administrators, isn't it? But anyway, that's what the business guys were doing, sort of thing. And so in the process, we of course tried to do our best to really meet those business demands and other things. And then I also realized how lucky I am being a university professor. The amount of freedom which I have as a university professor in choosing the problems which I am passionate about, problems which I want to work on, problems which I really feel worth solving, and without being told by anybody else, is really, really a privileged position. And in fact, I started appreciating my university professorship much more, and I'm enjoying it thoroughly, and of course having great fun with working with my students and research fellows in the group.
That's until you get sent a piece of paper asking for the 52-day rule.
Sure, yeah, of course. But that's why I think is that, as you say, that what has changed over the last 20 years. And 20 years back, most of the administrators used to think that their job is to assist the students and staff to achieve their academic activity in the university. But now administrators think that their job is to tell the academics what to do. And there's been a big change, and I think there's a need to be changed back to the state of assisting researchers to be able to achieve their goals. Ultimately, the intellectual output which we are producing and training which we are doing are the ones, the real outcomes of the university, not filling forms and then writing reports.
So, who do you wish you had chosen to work with?
With this question, in my career, really what I experienced is how important is really mentorship. I really had two good mentors during my career, and I'm really grateful to these persons. And so therefore I also try now to give this mentorship back to young people, because it's really important that you have somebody helping you along the career path, also to challenge you. This is what I've found very helpful for me. So even if again or something, but in the end, then in hindsight, then I realized how these persons really, by challenging me, helping me to get along, to really progress, to pursue a research project, also to make the next step in my career.
So how did you find these people? Or how did they find you? And how did they help you?
I guess I didn't particularly search for the people. I guess I meet so many people, and then I sort of realize these people, they are helping me. Also, as we talked about it, the chemistry is right. And so that I then try to stay in the research group of these people. Mm.
So, is there any other people who you would like to work with in the future, or from the past? So, is there famous figures from the past who you would say, I'd like to work with Nobel Prize winner X or Y? Or
not famous people.
Mm-hmm.
It's really that. Recently, when half a year ago, when I went to Germany there, I got to know there a group of several people, and they are doing really good complementary research. Mm-hmm. And so with these group of people now, I'm really looking for mechanisms, funding opportunities, so that I can forge a close collaboration with them. Mm-hmm. Mm. But this is more driven really by the research idea, the research topic, because I can really see that because they're doing something which I can't do in my group, and so it's perfect then to work together.
So, Jagadish.
Well, of course, I wish I had the opportunities to work with smart people. Those are also generous. There are a lot of smart people, but not all smart people are generous, and then it's important to really have people, those who are also not only smarter than I am, but also generous, and so thereby that's where I think you really have got, it's a pleasure to work with people, sort of thing. Mm-hmm. And some of the people whom I can give examples is Alan McDermott, and whom he was a great human being, and of course he passed away, and then so he came from a modest family in New Zealand, and in fact when he was young, his father lost his job in one of the wood mills in New Zealand, and then became a lab assistant in Victoria University in Wellington. And then while being a lab assistant in a chemistry lab, he did his bachelor's degree and ended up going and doing PhD, one in Cambridge and one in US, and is a great individual, very generous individual. And then he could talk to high school students and also the Prime Minister at the right level to be able to really communicate with them effectively, and he was always willing to give something back to the community, and that's, I think people like that are really pleasure to. I've been lucky to have, I can call himself as my friend, and so, because that's the thing, of course he's got a Nobel Prize, but that Nobel Prize is a secondary part of it, but as a human being, he's got a great spirit, and people like that really are really wonderful people to work with, mm-hmm. and that's also very inspiring to work with people like that.
So do you think, looking at the sort of time history of your fields, so you wouldn't say, you don't look back and say, I would have really liked to have been around in this particular era, or?
Of course, I mean, the thing is that early 1900s is the best time, and then lots of fun stuff is happening by Einstein and Bohr and all these guys, and there are some stalwarts of our field, so really the ones, that's a period which would have been great fun to be around and then be able to contribute to our discipline, sort of thing. But of course, we're not living in that world. I'm probably 100 years too late for that. And so, but of course, that was an era where it's phenomenal. People, those have really developed quantum mechanics and atomic structure and radioactivity and general relativity, and there's so many things they've done. And the thing is, it was an era which is really phenomenal era, sort of thing. You wish you could have been there and be able to also make a huge contribution to the fields.
And there was no email?
Fortunately not.
So, last question. If not you, who would you like to be?
I really don't know. I wouldn't say that I'm too happy with myself, but I really find it challenging to think of another person where I would say, oh, I want to be this person. It's rather certain
You can
traits.
think quite one of the last guests wanted to be Doctor Who, so it's the choice is wide.
Or maybe me 10, 20 years backwards and then start again and not making certain mistakes, and with a hindsight of a few things, having a slightly different life. This might be fun, interesting.
But you'd still go into the same field and proceed?
I would still do glass, I think, yeah. I came across the glass by chance. So what I try often is keeping an open mind, and then if then something attracts me, then I pursue it. And so it was just by chance somebody asked me, I was in my second undergraduate year also, if I want to earn a little bit of money. And so this person was from the glass chemistry. I thought, yeah, why not? A little bit of money is not bad. And so on. This was in glass chemistry, and I was so passionate about it. And since then, I really tried to pursue to stay in this field. And maybe, yeah, if what I sometimes think what would be nice to have sort of, yeah, the courage to maybe work a little bit less in science and do a little bit maybe in glass art, to be a glass artist.
Artist?
Yeah. This is sort of my dream.
That's on your bucket list?
Yes, it is.
Jagadish.
Well, of course, I'm happy to be who I am, and I think it's, I don't think I'll change too much, but of course, I wish I could be somebody like the people, those who are very smart and able to make a broader impact in the community, people those who are working and solving problems of the world, poverty or the child mortality, or or problems like mental health problems of the community, or there are so many things, blindness, for example, Fred Hollows type people, and then I wish I could be a person who could have a bigger impact than in my own field of science, and then of course I try to do my best to do my science and then be able to make an impact within the scientific community and then contribute to the broader scientific community. But there's more to life than science itself, and that's where I admire people, those who are making a huge difference in terms of the broader community. And then whenever you hear some musician going and then playing music to the homeless people in Los Angeles, and then be able to really help them in terms of getting over their mental health problems and those sorts of things, when you look at that and then, I wish I could have had small abilities of similar nature so that I can make a bigger impact than what I'm able to do just in science. So
are you a musician?
I'm not a musician, of course. I love music, I love art, but I don't know how to play any instrument, or I don't know how to draw. And of course, some of the people whom I admire in the art field are the Vincent van Gogh. And again, perseverance, when you talk about perseverance, and here is a person who didn't have any food to eat, and today we admire his art, and then they are sold for $30 or $40 million each, sort of thing. And his brother had to send money for him to survive. And then in fact there's a novel called Lust for Life. If you're really keen on learning about what tribulations he had to go through, no appreciation in his life, and nobody appreciated his art and other things, it's worthwhile to really read that. In fact, I used to keep that one in a book. Every time I got frustrated with something or the other, and I used to read one page of that book, then I said, gee, my problems are really trivial when compared to a talented guy like Vincent van Gogh, who had to go through what he had to go through. And another book called The Agony and Ecstasy by Michelangelo's biography again. And again, he's a talented artist, but what he had to go through, sort of thing. And Agony and Ecstasy by Sigmund Freud's tribulations of his new theories in psychology, and then how difficult it is to get the acceptance and all these things. And they're all admirable people. And so it's really fascinating to see, despite all the adversaries and very little appreciation they pursued, and then we are, as a world, we are richer because of the people of contributions and the perseverance of people like that.
So you mentioned earlier that initially you set out to be an engineer, but ended up being a physicist and then coming back. Would you have changed that trajectory?
Well, if I look back, I have been lucky. Sometimes, things may not go according to plan, but sometimes, everything happens for your own good. So that's what I feel. And if I had been an engineer, probably I would have worked on engineering aspects of it, because of the fact that, by the way, if you're born in countries like India, you're expected to be an engineer or a doctor, and then generally those are the positions which you end up leading to a good job, and then that helps you in terms of having a status in the society, and that's the expectation from your parents. And so let me tell you that my daughter, when we were visiting, and then she finished her year 12 about 3-4 years back, and then everybody was asking, are you going to do engineering or medicine? She said, I'm going to do visual arts at the ANU. They looked at her, what's wrong with you, sort of thing, So that's sort of course, the background which you come from. And actually, it's a good thing that has happened. And so probably if I would have gone into engineering, but probably I would have been working in some government engineering position or the other. And because of the fact that I've taken a different trajectory, and this really led me to where I am today, and which is allowing me to have great fun. So that's why sometimes you may be aiming for something, and then your life takes you in a different direction. Don't get too depressed, and then try to see that, make use of that opportunity. And if you really still want to do that one, and then you can go back and then try to do that one too. In life afterwards, you may get those sorts of opportunities. And so it's always part of life, in my view. It's fun. It's fun.
So that concludes my 10 questions that I have on the list here. And we open up the floor now for members of the audience. So do we have any questions?
Hello, I was wondering, how do you choose students or people to work with you? What do you look for in people to work with you, and students that apply to work for you?
So
how do you choose them? What do you look for?
Okay, looking for students.
Yeah.
And okay, go ahead, Heike, you go ahead first. You are the guest here.
Didn't we understood the question?
So how do you look for students?
Yeah, so I guess so you'd have lots of people applying to work with you, or lots of students applying to work with you, and what are the qualities that you look for in a student that would be wanting to work?
This is an area where I'm really recently thinking more and more, because I'm a research-only academic, and so I really find it hard. So apart from that, I get a lot of emails where people come and want to do a PhD, and so far I was really lucky that people really approached me, and so that I even had the choices of who I could take on for PhD projects. I find this now that I'm at a stage where I'm still thinking what's the best option or way for me to go out there to find the right people, the smart people.
Of course, first and foremost, excellent track record in terms of academic credentials, and also coming from good institutions, because of the fact that you really don't know institutions which you don't know. They may be excellent, but you're taking a bit of a risk, and that's why you go for institutions which you know, and you had the experience of students came from those institutions, have done very well in your group, and then you've got a good experience from that point of view, and then they've got good academic credentials, and then the combination of those two, then we just go and then see. And most recently, we have been start doing Skyping, so really you can talk to them and then see whether they can, whether sometimes some students on paper they may look good, but in reality they may not be as good. So that also sometimes leads to frustrations, and that's why talking to them on Skype and other things, you should got some feel for it. And so in fact, most recently there was a student coming from India, from an excellent institute called IIT Kanpur, and that's probably one of the top institutions in the country. And he's got excellent track record, and with a master's degree from that institution, and then getting into that institution itself becomes very, very difficult. So that means he's must be very good sort of thing. But poor guy is struggling to pass his English exam. And then of course, unless otherwise you pass the English exam, and the university says that we cannot really offer the fellowship or the PhD scholarship sort of thing. I happened to go to the conference in IIT, and then I happened to talk to him. His English was fine. I didn't find anything unusual. Of course, he's got strong Indian accent, but of course, he's an Indian guy. What do you expect? You can't expect him to have York accent like Lenny. So it will be a different accent. So, but then we asked him to keep taking, and he took 4 or 5 times. But ultimately, we said, look, this is not working. Let us see what we can do. And then I asked a couple of my young colleagues, Dr. Hotan and Dr. Lan Fu, can you Skype and talk to him and then see what do you think of it? And they both said, look, his English is fine, there's no problem. Then we could go to the university and then seek exemption for his English sort of thing. And sometimes, when some of their administrative process may limit, then particularly got excellent students, and because apparently it turns out that the software which they're using for his English exam doesn't understand his accent. It doesn't surprise me. Every time I try to order a taxi using Allied taxis, and a machine never recognizes my voice, and then that's why I have to really wait for the operator so they can understand why poor guy is having difficulty sort of thing. So that's why, again, it's important to really treat individuals as individuals and then see, and then really go a little bit deeper. But of course, when you're getting weekly about 6 or 7 applications, how do you really cope with it? And that's why you go and choose the academic track record, institution which you know that they're excellent institutions from any country which they're coming from, and then you go and choose those one sort of thing. But sometimes even you go choose them that they don't get visas, and then I waited for 18 months for an Iranian student to come through. He's a bright student and from one of the top universities, and then I know many of the Iranians, those are doing extremely well in the US coming from those two institutions, but he didn't get visa. So these things happen sometimes.
But have you had students who have exemplary track records in terms of their grades, but you would say to them, I don't believe this PhD or a graduate student is right for you, at least not at this time?
So in fact, anytime anybody wants to do PhD, I ask them why you want to do PhD, and I have discouraged some students doing PhD when they told me, well, oh, isn't it the logical thing to do for me next? I said, no. You really only should go and do your PhD if you feel passionate about, that's what I want to do. In fact, one of the students who did his honors from engineering program, and then after finishing, and he came and said, do you want to do PhD? Then I said, why? Well, I finished my bachelor's degree, and then all my other colleagues are doing the same thing. What else you want to do? Really, I want to go and work in industry. And I said, you better go and work in industry first. If you really don't like industry, you can always come back to me. And that's what happened after 1.5 years or so. Then he got fed up with the routine stuff which he was doing in that place. And then he came back and came and did his PhD with me. So that's why it's important to ask the question, why do you want to do PhD? That really gives very, very interesting answers. And that's why they really need to do the PhD for right reasons. Not because it's I finished my bachelor's degree or master's degree as the next step. That means they really are not doing PhD for the right reasons. And that means they may not have the same motivation and all these things. But of course, that's where sometimes I've had students, those who are not motivated, and one student, in fact, got excellent track record from University of New South Wales, and so she used to lie down in the couch and reading the German Greer books when our director was passing by and all these things. I used to have a chat with her, and one day she came and said she wants to take 6-month break and want to go to South America, and then she has gone to South America, traveled, came back. She was a completely changed person. Within 18 months, she had 9 journal papers, got a great thesis. Now she's working for the government, and I think she's really climbing up the ladder very quickly because she's got excellent communication skills, very smart girl. But sometimes that motivation is also an important thing, and then that's where I think we need to work on how do we motivate our students to really achieve their full potential.
So given that our dean is currently in South America, I'll expect him to come back as a reformed fellow.
I'm sure that he'll be more motivated, I'm sure.
Do we have other questions?
So I'm interested to know how you balance research and family.
Sorry?
I'm interested to know how you balance research commitments with family commitments.
So research, balancing research versus family.
That's a tough one. I'm really the wrong guy to answer that question. I'm hopeless, because I spend almost 6 months in a year outside the country, traveling all the time. And how do you really manage that sort of, that's always a tough one. In fact, if you ask me, do you have any regrets in your life? And the only regret in my life is that I wish I would have spent more time with my daughter when she was little. She's 22, she doesn't need me anymore, she's got a boyfriend and other things, but when she was little, when she needed me, then I was always busy trying to build up my own research group, and of course it's a new department, and then we didn't have any equipment, and of course I'm a new guy, and I have to prove myself that I'm worthwhile to be at the ANU. Premier university in the country, and that's always a bit of a challenging act sort of thing. So that's where I think you need to ask yourself the question that what do I want to do in life? And I think a balance in life is very, very important. And if I look back and then say that, well, maybe you could have worked less hard, maybe I would have taken 1 more year to get my promotion for one thing or the other, I would have probably published a slightly less number of papers. At least I would have enjoyed my daughter's childhood, and I would not encourage you to really go and then compromise your family life, and that's where I think you really need to look at and then see what is important for me in life, how do I really balance these one sort of thing. And it's always, life itself is a balancing act, and then it's a matter of prioritizing those things and then making sure that you do this thing. If I would have known this one, then probably I would have spent the evening times with my daughter, would have worked after she's going to bed, for example, which I didn't do that sort of thing. So that's sort of, it's always a bit of a tough challenge, because the system is expecting you to perform a lot and then be able to survive in the funding programs and other things. You need to expect you to publish papers and other things, but also your family needs you at the same time. And but of course, if you're not working and successful, probably also you cannot pay mortgage also, so then it's one of those things also becomes a challenging issue. That's why I think it's important for you to really look at it and then see what is important for you, how do you really be able to manage that, the competing interest sort of thing. And that's where the time management becomes important. So that's where again, sometimes we end up doing lots of things probably which really we should not be spending as much time, we end up spending time on, and prioritize what is important for you and then focus on the important things first, and then probably allow the non-important things to linger around, and then probably make sure that you go and spend that time with your family.
It's really, for me, it is really a tough question, a tough thing to do with to get the right balance. It's really what I try to learn more and more, to say no, so that I have more time for my family. And so I also make more conscious the decision, no, this evening I don't work, I don't look at emails or so, because then I know that the next day I'm much more refreshed. And so if I work less, I can achieve more, I also realized. And so I make more now. In the past, I was really more driven, oh yeah, I have to do this, and wasn't looking so much how much I spent my time for work and for my family. And I do this now differently, more consciously, and I think it really helps me.
Thank you. My name is Raj. Professor Jagadish, you did mention about young, intelligent scientists and being generous, giving back to community. Do you think the university is molding its young scientists to be more generous in future?
Somehow the acoustics is not good, so it's difficult to understand.
I said, do you think the university is molding its young intellect scientists to be more generous in future?
Probably not. That's where I think the challenge comes. And so sometimes the thing which I say is that the pleasure of giving is much more immense than pleasure of taking. But then you have to pity people, those who have never experienced the pleasure of giving. Okay? So the pleasure of giving is something which you need to really realize, that you're doing something for somebody, and then it makes it could be your student or your postdoc or anybody, and then that makes their career better, or otherwise it helps them in solving a problem or whatever it is, and it's immensely satisfying to see helping that person to really achieve their own goals, sort of thing. In terms of, because of this competition, there's always a problem, but because of the fact that funding agencies and other things are always looking at what is your contribution, and if you go to promotions, and in fact, we work as a team, and I've got 2 other colleagues, and then always a challenge comes, what is your contribution and what is your, Jagadish's contribution, sort of thing. So that's where it's important to really, working together as a team is a good thing, and then you really need to make sure that they really be able to articulate their case, that they are contributing specifically, and it's my job to make sure that I can really emphasize and amplify their contributions to our work, so thereby they are not disadvantaged. And again, that's where the group leaders and then the people, those are mentoring people, play an important role in that, from that point of view.
It's really to find the right balance
Yes.
between competition and really collaboration. I think within the group, it's good not to have too much of the competition, so that a little bit, because this is important, you compare yourself with others, and then you of course want to be better, and this drives you also. But it's also to have, what I find important really within the closer group, the 20, 30 people you work most closely, that you nurture the giving, the collaboration, and it really pays back.
So for me, it's very important, not only the person who is joining my group is smart and hardworking and all these things, also they fit into the group. They may be prima donnas, but if they don't fit into the group, they change the entire group dynamics, and it's extremely frustrating. And then they create so many problems, and then you're spending a lot of your time in solving those problems. So that's why fitting people, people those who can fit into the group is also an important aspect of it. And again, that's why these days, any endeavor which we are doing, and it's a big, larger team, so that's why your ability to really work with other people and then be able to contribute to the broader good under a broader projects, it becomes also an important thing, and that's a skill which we all need to learn.
Any other questions?
Scott Lang from the Australian Electoral Commission. Thank you both for talking to us today. I'm non-academic, but I was curious, Professor Jagadish, about what you were saying about working with businesses. As academics, would you generally try to come at it from the point of view of your audience, as you've said in some things, and go to them with a specific solution to a problem? So, you know, kind of say, listen, I've been looking at your industry, this has been a long-standing issue for you guys, I'd like to work with you to solve that particular problem. Or would you kind of choose your field first and then try to narrow things down and eventually get to the point where you have a research topic and take that research topic to industry to see if they're interested? Which way would you go about it?
First and foremost, you need to develop the core competency in skills in certain area before industry wants to talk to you, sort of thing. So from that point of view, if you don't have core competency, industry probably doesn't care about you, sort of thing. So that's why it's important, first and foremost, you develop the core skills and your ability to solve problems, or, you know, means developing a new algorithms for solving something, or, you know, developing a new widget or whatever it is, sort of thing. In terms of industry, I mean, by the way, though I've joked about I don't want to become a CEO, we closely work with industry. And most interestingly, that I found, particularly when my students are now running companies, when I talk to them, sometimes in the universities we think this is a problem for industry, but when you talk to your students, those are running companies, they tell you, really that's not really a problem for us, this is a problem for us. And then you don't realize that, because the thing which you're imagining is a problem is not a problem because they know how to get around it, or it's not really that important from their perspective, but this is a problem. But that's why having that interaction will help you, because in the universities we love to solve problems, and that's what is really fun part of it. And why to solve an imaginary problem? Why don't we solve the real problem? So that's why working with industry helps from that perspective. But again, industry only wants to work with you. You have got some core competency and something which you can uniquely contribute to them, then which they do not have the abilities in terms of either the facilities or the expertise. So from that point of view, that becomes an important thing. But of course, if you develop some new technology, if you feel that that will be of benefit to the industry, it's always worthwhile to make them aware of it. But then most of the time, industry is so well focused because they cannot afford to go and diversify themselves too much, because that means they will not be able to really produce the stuff which is needed to be produced to be able to be in the game and then be able to survive. So at least they're aware of it, and then they may come back to you and then they may say that, look, you know, that's not major interest to us, so be it. But I think that interaction is an important thing and is a beneficial thing. And so I enjoy working with industry, though my research is more of the fundamental end of the spectrum to close to the industry level sort of thing. That's why our research really covers a broad spectrum. And it allows you to identify the problems which are real problems which are of interest to the industry, and also make industry aware of what skills and expertise or the things which you can really provide to them.
So it would be a good idea, for example, to network well beyond the university itself, so that before you get to the stage of approaching industry formally, sure, you might have actually talked to someone at a dinner or a conference or whatever and said, listen, I think this is a problem, but is it in fact the case?
It is important to really do that one. In fact, in Australia, we are not that good at it. I mean, so we are good in innovation in terms of the science part of it or engineering part of it, in doing research and publishing papers, training people and all those things, but we are not very good in terms of translating those innovative ideas which we are exploring in the university sector into commercially viable technologies and things like that. And one of the reasons is also there is a big gap. And that's something which we really need to really fill that one, and that's where the governments have a role to play in terms of really providing the right entities with the right skills to be able to really translate a device which you make in a lab to a commercially manufacturable product, for example, before industry really takes it seriously, and then be able to really take it up and then be able to pursue that sort of thing. So that's why that interaction is an important one, and we need to do more. And with respect to what we are doing now, and in fact I run an Australian nanotechnology network, which is a network of research community, and in fact now we are working towards really how to bring the industry on board so that there's interaction taking place between researchers and industry sector. The problem is that industry is also under enormous pressure to really meet their own goals, and they really do not have that much time to really go and then spend time in these sorts of things, and that's where the issue comes, and that's where I think more effort need to be done from our side, because of the fact that they probably have got enough problems to really worry about in terms of their next quarter balance sheet sort of thing. So that's where the challenge comes.
Anything to add?
What I learned along the way with industry is really not to overpromise, really show your expertise, what you can do, but also show them where are the limits, how far what have you achieved so far, but what you don't know, so that they are aware of it and that they don't have wrong expectations. So this is what I learned along the way, also not to create a wrong expectation, because can be then, it's then very hard really to build a good relationship.
Yeah, on that note, I can also say that if you are not the expert and there is somebody else who is better than you, just better direct them to that person. Then, oh well, they'll give me 10,000 or 20,000 if I do this one, but you're not the expert, and then you will take longer, and then you've got a sour taste on both sides. It doesn't really help anybody. So that's why if you got the core competency, you can really solve the problem, agree to do that one, and also do it as efficiently as possible. Or otherwise, if you're not the expert and your colleague, not only in your own university, but some other institution, better direct them to that person. That's what I do quite often.
Yeah.
It's very, very important, because that way they have got a good outcomes from their point of view that helps them to really go and interact more with the university sector or the research sector. Then if got this bad feeling, then they say that, look, it's not worth wasting their time. But of course, many times people do tell you that they've had bad experiences of working with some of the research community, because the research community sometimes underestimates the time it takes, the resources they need take in order to solve a problem, sort of thing. And so that's a challenge.
So I'm going to finish off with the last question. So where do you see universities in 50 years' time? So we're in an era of quite a lot of change, particularly with things like mass online education. It's been stated that that may be a disruptive technology, particularly in the university setting. Will there still be universities? Will there still be opportunities for building your research labs, etc., in these sort of environments?
So, I mean, my view is that yes, universities will be here even in 50 years' time, but of course the way we do things will be changing. And just to give you an example, and most recently there is something called Khan Academy. I don't know how many of you heard of this. This guy called Salman Khan, and he did his undergraduate degrees from MIT, and he was working as an analyst at a hedge fund in New York. And his cousins were asking him to help him with some science and or maths and physics problems. And then he was trying to explain them by phone, and then they were not really getting what he's saying. So what he does is that he works out a maths problem and then takes a video of that one and he posts it on the YouTube. And then, of course, not only his cousins have downloaded that one, and many other people downloaded and started leaving comments saying that how much they appreciated and they learned. And then he quit his job, and now he started this called Khan Academy. His aim is to really provide free global education to the global population. It's a non-profit organization, and people like Bill Gates and others are supporting that one. And in fact, I've gone and then downloaded a couple of lessons and then tried to listen to that, and it's been really nice to really see that sort of thing. So if that's the case, then you ask the question, so that means, we don't need lecturers and the professors and the universities, and then, everybody will be going and downloading the internet and other things. I don't think so. But what's going to happen is that, in fact, this Khan Academy's case, a school district in California have chosen Khan Academy as their partner, and so the Khan Academy is now developing the various lessons for the curriculum which they have got, and then students are advised to download those lessons, listen to those lessons, come to the classroom, where now the classroom becomes a discussion session, and be able to understand which they haven't understood from that process. So that way it becomes a much more interactive process, rather than a teacher is writing down and then doing this thing, you're taking the notes and there's no interaction, and then people are sleeping off or dozing off and got bored and then checking their text messages or one thing or the other. But now this became very, very interactive thing. So I think, in my view, the technology is going to really change in terms of the way we learn, and then that will also, in fact, removes all the boundaries and then the constraints, and then hopefully will be, in fact, become hopefully a better society, and then also better educated society as a global society. And my view is that universities will stay. But of course, in terms of experiments and other things, of course, you just can't do in the virtual world, and though you can do simulations, and so then, of course, you can really get some idea, but at the same time, unless otherwise you do the real experiments, you really don't understand the simulated experiment and then the real experiment, and what are the differences and other things. And there's always you only do the idealistic situations when you do the simulations, and the real world is quite different, and that's where the experimental work will go on, sort of thing. And I think we'll be doing it differently, but still I think the universities will be there for the next 50 years or so, or even in 50 years' time.
So, okay.
Yeah, I fully agree that I also think the universities will be there, but how we teach people that this will be changing, the type of lecture which is still around there, that somebody is talking and the others are listening. I think this will, or I hope this will gradually disappear, and that there's really more interaction between students and lecturers.
So I'd like to conclude there, and conclude by thanking both of our guests, Jagadish and Heike. Thank you very much for participating in this event.
Thank you, it's been a great pleasure. Thank you.